Pluto reimagined. From forgotten world to living frontier, the James Webb Space Telescope, humanity's most powerful and precise eye on the cosmos, has forever transformed the way we look at Pluto, and the role it plays in the frozen reaches of the outer solar system. For much of the 20th century, Pluto existed only as a faint speck of light, a mysterious dot moving across astronomers' charts. It was considered nothing more than a frozen leftover from planetary formation, a tiny and insignificant wanderer, drifting quietly at the edge of the sun's domain. Too far from warmth. Too distant for energy. Too geologically quiet to matter. In the minds of many, Pluto was a cold, dead, and forgotten world. Even its discovery in 1930 did little to change that perception. Yes, it was hailed as the ninth planet, but it was small, dim, and remote, barely clinging to the definition of a world. For decades, Pluto remained an afterthought in astronomy, a lonely outpost orbiting in the icy shadows beyond Neptune. Then came the year 2006. Pluto was officially stripped of its title as the ninth planet. It was reclassified as a dwarf planet. For countless people, this felt like the end of its story. Pluto had been reduced to a cosmic curiosity, a relic of the solar system's icy outskirts, destined to fade from memory. But the James Webb Space Telescope shattered that old image. Its extraordinary vision, capable of capturing the faintest whispers of infrared light, has revealed Pluto in ways no human eye or spacecraft ever could. What it found was astonishing. Pluto is not a silent, static ball of ice. It is a complex, dynamic, and unexpectedly active world. On its surface, cracks, ridges, and shifting planes hint at hidden forces below. Beneath the crust, convective activity stirs slowly but persistently, telling scientists that Pluto's interior is far from still. The colors of its surface reveal a chemical richness never imagined. Patterns of frozen nitrogen, methane, and carbon dioxide are spread like paint across an alien canvas. Shades of red, gray, white, and brown scatter across the dwarf planet, reminding us that even in the coldest places, nature paints with variety. At the center of these revelations lies Sputnik Planitia, a vast, heart-shaped plain that dominates Pluto's face. For decades, scientists believed it to be nothing more than a flat sea of frozen nitrogen. Cold. Empty. Unmoving. But JWST has uncovered a deeper mystery. Beneath that plain may lie a hidden ocean, insulated from the vacuum of space by a thick crust of ice. An ocean that could remain liquid for billions of years. If confirmed, this would mean that one of life's essential ingredients, liquid water, exists even here, at the frozen edge of the solar system. Suddenly, the impossible became plausible. Could life exist so far from the sun? This possibility has electrified astrobiologists. If microbial ecosystems thrive within Pluto's buried ocean, it would expand the definition of habitability itself. Pluto's surface, too, tells a tale of renewal and change. Towering mountains of water ice, harder than steel in Pluto's frigid environment, rise as tall as the Himalayas. Smooth, crater-free plains stretch for hundreds of miles, evidence that Pluto has been resurfaced in geologically recent times. Deep within, Pluto's rocky core generates heat through radioactive decay. That heat churns the interior, allowing nitrogen ice to flow like slow rivers across the plains, reshaping the landscape as though Pluto were alive. Pluto is no longer dead. It is restless. Pluto and Charon. A binary world of mystery and possibility, but Pluto's story does not end with itself. It is forever linked to its largest moon, Charon. Unlike other planetary systems, where a moon simply orbits its planet, Pluto and Charon orbit one another around a shared center of gravity. This makes them a true binary system, the only one of its kind in the solar system. This dance pulls at their interiors. Tidal forces twist, stretch, and knead them like dough, sustaining hidden activity deep within both bodies. Charon's surface bears the scars of this interaction. Immense canyons cut across its crust. Jagged ridges rise up, shaped by forces beneath. Its reddish hue may even come from gases escaping Pluto's atmosphere, painting its icy face in alien tones. Some evidence hints at an even deeper connection. Material, ices and organics, may be traded between Pluto and Charon, flowing back and forth in a silent exchange, enriching both worlds with shared chemistry. Together, Pluto and Charon are not lonely wanderers. They are partners, a cosmic pair locked in a gravitational embrace, evolving side by side at the solar system's frozen edge. JUICE's unmatched ability to capture faint light has uncovered more than landscapes. It has revealed Pluto's fragile, shifting atmosphere. Composed mostly of nitrogen, with traces of methane and carbon dioxide, this atmosphere is unlike any other. It expands and contracts as Pluto orbits the Sun. When closer to warmth, ices sublimate into gas, creating a delicate veil of air. When farther away, that veil collapses, refreezing as frost upon the surface. A cycle of creation and destruction found nowhere else in the solar system. Floating within this thin air are tholins, reddish organic compounds created when ultraviolet sunlight strikes methane gas. These tholins stain Pluto and Charon with streaks of red and brown, painting them with alien colors. But tholins may be far more than pigments. They may be the very first steps toward life itself. The building blocks of biology waiting for the right conditions. Could these molecules sink into Pluto's hidden ocean? Could they mix with warmth and liquid water, sparking the chemistry of creation? The thought is staggering. On Earth, life thrives in the darkest depths of the ocean, feeding on heat, minerals, and chemical reactions, without a single ray of sunlight. If Pluto's hidden ocean offers similar conditions, it too could harbor life. Perhaps microbial colonies. Or perhaps stranger, alien ecosystems, beings shaped by icy waters, crushing pressures, and chemistry unlike anything on Earth. Future missions could uncover the truth. Orbiters scanning Pluto's skies. Landers drilling through its icy crust. Even robotic submarines plunging into its secret ocean. The challenges would be immense, but the discovery of life on Pluto would change everything. It would redefine humanity's place in the universe. Even without a strong magnetic field, Pluto interacts mysteriously with the solar wind. Streams of escaping particles shimmer through its thin atmosphere. These discoveries reshape not only our view of Pluto, but also our understanding of the Kuiper Belt, the vast frontier of icy worlds beyond Neptune. Pluto is no longer a forgotten relic. It is a beacon of curiosity. A living reminder that habitability may exist in the most unexpected corners of the cosmos. Could its buried ocean shelter microorganisms? Could its strange chemistry mirror the processes on distant exoplanets, orbiting faraway stars? For now, the answers remain locked beneath its frozen shell. But one truth is clear: Pluto's story is unfinished. It will continue to inspire exploration. It will challenge everything we thought we knew. And it will remind us that the universe still holds endless surprises, for those bold enough to